Hello, in this video we're going to talk about cryptography. I'm just going to take you through the overall concepts, so we're not really going to get into the details of the mathematics. With cryptography, we have some information that we want to encrypt. We refer to this as the plaintext, and the plaintext is encrypted to what we call the ciphertext. So that's a text that can't be read or understood by anybody. It obfuscates the original text. To do this, we use an algorithm or a method that we call a cipher. So a cipher could be something really simple, like a Caesar cipher that's just replacing letters for particular other letters in the alphabet. So this encryption can go both ways with a traditional cipher. There is, of course, a problem with this approach, which is that if your enemy figures out what your cipher is, you would have to come up with an entirely new kind of cipher method to be able to send messages. To solve this problem, they came up with the idea of using a secret key. Using a cipher with a secret key, we're using something called Symmetric Key Encryption. And that means that the cipher can now be public. It doesn't matter if your enemy discovers the cipher. And if they should discover your secret key, it's a trivial process to just generate a new key. The key is just some piece of information. It's not a method. However, this doesn't solve all problems. So there's an issue of key management. So to illustrate this, I'm going to use an analogy. So we got this little Lego girl here, which is Leia, and she wants to communicate with the Rebel Alliance, Han Solo, Chewbacca. So we have one problem, which is that Darth Vader is looking for secret messages from the rebels. So what's Leia going to do? Well, one solution is that she gives out all these different encryption keys to her buddies. And this is normal for symmetric key encryption. You want to have different keys for different people because you don't necessarily want people to listen into each other's conversations. You can see that there's a problem with this method is that it quickly becomes a problem having all these keys to manage, and Leia also has the problem she has to somehow get the key to Han Solo, Luke, Chewbacca, and so on. To solve this, they came out with what's called public key encryption. And I'm just using an analogy here. So we're using a key as the private key and a padlock as the public key, but obviously in real life, this is just mathematics. The private key and the public key are just numbers that you combine in a particular way. And there's not really a fundamental difference between the private key and the public key. You can use both of them for encryption and decryption. The only catch is that if you use the private key for encryption, then use the public key for decryption and vice versa. So with my analogy here, we're going to swap around what's going to be the public key and private key later, but this is just to help you understand the basic concept. So what Leia will do is she will send out this padlock to all her friends, and it's not a problem if Darth Vader discovers the padlock. He can't really do very much with the padlock. To show you how this works is imagine that Chewbacca wants to send a secret message to Leia, and he has Leia's public key, but only Leia has her private key. So Chewbacca, he writes a message, and then he puts it in a box and puts her padlock on it. Now, if Darth Vader's eavesdropping, he can't open this one because the only thing he's able to get hold of from Leia is her public key, the padlock. You can't open a padlock with a padlock, obviously. But Leia, of course, she can open it with her private key. This doesn't solve all problems with communication. We also have the problem of identity. Darth Vader could, in principle, grab hold of her public key and use that to send messages to her, and she wouldn't really know if it's from Han Solo or Luke or Chewbacca. Darth Vader could just say, this is from Luke, whatever. What we're going to do is we're going to create digital signatures to prove who somebody is. So in this case, we have to swap the private key and the public key. What's going to be the padlock and the regular key to the padlock. But that's fine because these are just numbers, so it's not really a difference. So the way this works now is first you have to, of course, make sure that they're distributed. Of course, they would already have been this if it were used for encryption. So imagine that Leia wants to send a message to Chewbacca. So she puts the message in a box and sends that. Now, Darth Vader could, of course, open this and look at the message. So that's not a problem. So it's not really a way of keeping secrets. However, Chewbacca knows this message could only have come from Leia because he can open it with Leia's public key. If Darth Vader sent a message and he used his own padlock, of course, Leia's key wouldn't work for that. So we use both of these methods. For public-private key encryption is used both for sending secrets and for verifying identity using digital signatures. Another important thing to know is hashing. So with hashing, we have some kind of information that we want to turn into a single number, basically. So we start with a message that can be any kind of information, and then we use a hashing function. And you got to remember that this is a one-way function. So what we get out of this is a hash, but there's no way of turning hash into a message again, because you can take 20 gigabytes of data and then just turn that into a 20-byte hash. So obviously there's no way of going back from that. There's many different names for hash. We also refer to it as a digital fingerprint or a message digest. It depends a little bit on the context. So let me show you how we would use a hash with encryption. So imagine that we want to have a signed message, as we talked about earlier. There's some information. Maybe it's a contract that Bob wants Alice to sign. So we would refer to this as a message, and then we want to have a signature in that. So how does Alice do that? Well, first she will use a hash function to create a digest, and then she will use her private key to encrypt the digest, and this is what gives us the signature. Now Bob can get this contract with the message and a signature, and he can check whether the signature is valid by first hashing the message to get a digest, and then decrypting the signature using Alice's public key. And then finally he will compare these two digests and see if they're the same. So if anybody made any changes to the message without altering the signature, then the digest from the message wouldn't be the same as the one from the signature. And of course, if somebody tried to create a signature by using a different private key, then it wouldn't match up either. You couldn't decrypt it using Alice's public key. So why do we use a digest? Well, the reason is because symmetric or public-private key encryption is really slow, so you don't want to use it to encrypt a lot of information. So that's why we typically like to do a hashing first, because then we have a small piece of information that we have to encrypt.